Let's talk about scientific notation. Another one of those topics you've probably learned a bunch of times, but maybe haven't thought about in a while. So sometimes we are asked to write a number in scientific notation. So if we're given, let's say, 250,000, and we want to write that in scientific notation. So the first thing we do is find a single digit number, and so a number less than 10. Basically, we're going to move the decimal point over until we get to 1. So if you move it all the way over, we have 2.5. So basically 1 from the left in this case. So 2.5 times 10. I'm going to start there and see how many places or how many places we're going to move to get to the number. So 1, 2, 3, 4, 5. So it takes 5 to get to our numbers. So we have 2.5 times 10 to the 5th. So when we have a positive exponent, we move to the right. Sometimes we have a decimal, so 0.000358, let's say. We still need a single digit number. In this case, it's 3.58 times 10. We're going to move to the left to get to our decimal point. So 1, 2, 3, 4. So 3.58 times 10 to the negative 4th. So a couple things to keep in mind with positive exponents. You move right. You make these little loops there, or these little, I don't know why I can't come up with the word, doesn't matter. For negative exponents, you move to the left. That's where you end up with your decimals. In the general form, we always have some number times 10 to some power. And that number, basically that always has to be a single digit number, because that's just the notation. That's just the convention of how this works. Whoever came up with scientific notation. It wasn't me. Okay. Sometimes we're given scientific notation. We're asked to write a number and write it in standard form. And that just means as a normal number, for lack of a better way to put it. So maybe we have 2.56 times 10 to the 8th. I'm going to rewrite this down here and then move over 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. Hopefully I can use my pen a little better, but essentially all those little empty spots we put in zeros. So 1, 2, 3, 4, 5, 6 zeros. So we end up with 2, 5, 6, and 6 zeros, which is 256 million. Let's do 1.603 times 10 to the negative 5th. Rewrite it, leaving space on the left because I'm going to the left. So 1, 2, 3, 4, 5, 0, 0, 0, 0. So I have a decimal point and I have 4 zeros and I have 1603. So the reason we like scientific notation is because writing numbers with a bunch of extra zeros just takes up space. So scientific notation just makes things a little cleaner sometimes. Sometimes we're asked to simplify expressions and write that simplified expression in scientific notation. For example, maybe we have, and by maybe I mean we do, because that's what we're writing, 5.6 times 10 to the negative 4th over 3.8 times 10 to the negative 2nd. So we can really just take 5.6 divided by 3.8, which is 1.47. And multiplication, that's fine, but now we really just have 10 to the negative fourth over 10 to the negative second. So we have 1.47 times 10. Negative 4 minus negative 2 is negative 2. So we have 1.47 times 10 to the power of negative 2. Let's do 2.56 times 10 to the negative first times 7.1 times 10 to the fifth. So 2.56 times 7.1 is equal to 18.176 times 10. Well, 10 to the negative first times 10 to the fifth, negative 1 plus 5 is 4, so we have times 10 to the fourth. So we're close, but we're not quite done because this isn't technically in scientific notation if we have a two-digit number. So this is kind of goofy, but what we have to do is on this side here, we need to move one decimal place to the left. So that's like dividing by 10. And if we divide by 10, we're going to have to multiply something by 10. So we're going to multiply that 10 to the fourth by 10. And we end up with 1.8176 times 10 to the fifth, because this is like 10 to the first. And if you want to check and make sure you're right, take your 18.176, and if I move 4 decimal places to the right, I have 1 0 at the end. And let's take 1.8176 and move 5 decimal places and see if we get the same thing. 1, 2, 3, 4, 5, and we do, so we're okay. Last one we're going to do that I'm going to show you is 8.15 times 10 squared to the power of negative 3. And we can really just distribute. So 8.15 to the negative third power is 0.001847. 10 squared to the negative third, 2 times negative 3 is negative 6. So we have times 10 to the negative 6. Similarly to the prior problem, this isn't scientific notation because we don't have a single digit number. So to make that work, we're going to have to multiply by 10 to the 1, 2, 3. So times 10 to the third. And if we do that, we'll have to divide by 10 to the third over here to make our equation still work. And so then we end up with 1.847 times 10. And if we're dividing by 10 to the third, we're essentially subtracting 3. So it's times 10 to the negative ninth.